All right, so section 5.3, dividing rational expressions with complex fractions towards the end. Okay, so real quick reminders. Let me put this right here. So reminder. You guys have done this before. So like if you've done 2/3 times, let's say, 5/10. If I told you to do that, okay, we've done this already. You can try to reduce, right? That's what you want to do. Reduce, factor, anything you can. But we can't factor monomials, right? 2 is a monomial, 3 is a monomial, 5 and 10, those are both monomials. So you can't factor them. So what you're going to do is maybe try to see if you can cancel stuff out. And I noticed diagonally, 2 and 10 can be reduced, but also vertically 5 and 10 can be reduced, right? So you get to choose whatever you want to do. I'm going to go with the easier one for me. I'm going to make this 5 a 1 and this 10 a 2. Now let me rewrite this. 2/3 times 1/2. Now yesterday a lot of you guys were like, man, I don't know if I'm done. And I'm like, well, they're like, you guys would be like, I reduced it already. I'm like, but can you keep reducing? Right? And they're like, oh, I can. Notice I have diagonal 2's there. I can cancel those. So this becomes a 1/3 times 1/1, which is a 1/3. And that would be my, that would be my answer for that. Okay? Let me get rid of that. So, I mean, that's multiplication, but today we're doing division. Okay? So how does that make anything different? Well, it's just a small little change. So I'm going to do the same problem, 2/3, but instead of times, I'm going to put divided by. Okay? So again, this is something you guys were supposed to have learned at least in Algebra 1, which would have been Math 1, but maybe even before that. I'm assuming maybe 7th, 8th grade. I just don't know how often you've used it, so maybe you don't remember. When it comes to dividing fractions, okay, I always say, this is what I tell my students, we don't divide fractions, we multiply reciprocals, okay? So we don't divide the fractions, we're going to multiply reciprocals. So that means I'm going to get 2/3, put times, actually let me change this to a completely different color just to make it obvious, times 10/5. We multiply reciprocals. That's what I mean. So you're going to put multiply and then take the reciprocal of the second fraction. And that's it. That basically today's whole lesson is based on you being able to do that. Change a division to a times and then get your second fraction and flip it. And then once you do that, do the work. Okay, the work that you did in section 5.2. So here we go. So now that I've done that, I look at 2/3 times 10/5. I can reduce 10/5, right? So 10 can be divided by 2. That gives me a 5. And 5 can be reduced by 5 one time. Oh, what am I doing? I'm sorry. 10 can be divided by 5. That would give me a 2. 5 can be divided by 5 as well. So that's going to give me a 1. Let me rewrite this. 2/3 times 2/1. Can I cancel the 2's? No, right? That's horizontal. You can't do that. Vertical or diagonal. Can I cancel anything else out? No. So I'm just going to multiply straight across. 2 times 2 is 4. 3 times 1 is 3. And there you go. Okay? So what we're doing today is the right side fraction type of work, okay? We're going to have a division of a fraction. So what we're going to do is multiply by the reciprocal, okay? What we did in section 5.2, which was on Friday of last week, was on the left side. We just multiplied straight across, right? But we did reduce, but we just had to multiply. So remember, today's assignment is basically Friday's assignment with a little twist in the beginning you make it times and flip the second fraction, okay? So here we go. So notice it kind of looks the same like yesterday's quiz. The only difference is it says division, right? So we're just going to rewrite. That's what we got to do. Rewrite this thing so it makes some sense to us in terms of multiplication. So this becomes 3r over 10 times 4 over 5r. Sometimes people ask me, can I reduce at the same time? Yeah, you can. I don't always do it just to not do too much at once. Like I said, since my notes are usually meant for people who aren't here and I have to PDF them and send them out, I try to take steps as descriptive as possible without too many shortcuts, because that way they can follow along. So this is what I have. Now at this point, I'm going to start to cancel. Okay, what can I get rid of? The r's, right? The r's are gone. Is there anything I can reduce? The 10 and 4, I can reduce it by what number? By 2. So 4 can be divided by 2 twice, and 10 can be divided by 2 5 times. Let me rewrite this just to clean it up. 3 over 5 times 2 over 5. Can I cancel anything else out? No, right? I'm good. So I'm going to multiply 3 times 2, that's 6. And 5 times 5, that's 25. And there you go. Unfortunately, there was a lot of people, and I'm not just talking about this class, okay, but in all the classes, that they were giving me the answer of 5 over 10 because they accidentally were adding. Once they did everything, they started adding the numbers. So I saw that they did most of it right, so I gave them most of the credit. But yeah, near the end, people started adding instead of multiplying, so it's unfortunate. So are we okay with this one? I mean, not much different from what we've been doing, right? Just one little step. The very first step, you just put times and flip the second fraction. That's all. So here's another one. We're going to simplify the fractions of 3 times p plus 5 over 3 divided by 56p times p plus 1 over 7 times p plus 1. This is a perfect example of what I told you, where people say, can I cancel immediately? Okay. The only reason why I worry about people canceling right away is because what if you see that right now diagonally you can cancel things, right? And you're like, oh, diagonally I can reduce it. But you can only do that when you're multiplying. If it says division and you cancel diagonally, you just got it wrong. So I tell people, why don't you just wait one step and then do what you want to do? Even if you see things match. Sometimes when you flip it, they don't match up anymore. So it's just better to wait. Just wait. Now here, it is safe for you to get rid of the p plus 1s and the 3s and then reduce 56 over 7. You can do all that right now, and you'd be okay. But like I said, I would prefer just wait, just in case, right? Don't mess up by accident and then the whole problem's done. So I'm going to go ahead and write this out. This is 3 times p plus 5 over 3 times 7 times p plus 1 over 56p times p plus 1. And at this point, feel free to start chopping up as much as you need. So what's one thing I can chop here? All right, p plus 1. Anything else? The 3's. That's pretty much all I can chop. Is there something I can reduce? The 56 and the 7, right? Because 7 goes into 56 8 times, right? So let me use a different color. I'm going to do it at the same time, but I'm just going to change colors. That way we notice. So 7 goes into itself once, into 56 8 times, okay? That way you don't see too much chicken scratch, because at that point you can get lost in your own writing. So on the left side, I have a p plus 5 over 1. And on the right side, I have a 1 over 8p. That's all that's left. So when I multiply that across, I get p plus 5 over 8p. And then I can cancel my p's, right?
No.
No. So many people did that yesterday. You know, Mr. Bond called me, and he was frustrated. And he's like, I swear these kids are testing like they've never seen this before. I'm like, I know. Sometimes you're looking at it and you're like, I literally did that. Yet, like, there was a problem that you guys had for the test that we did the day before. Like, it was the exact problem. And so many people didn't do it. I'm like, either they're not studying, they're not noticing. Like, not everybody. I'm just saying the kids that he's being frustrated with. I'm like, either they're just not studying, or they don't understand and they're not asking, or they're not paying attention. I said, because you guys have seen this so many times. We're like, so they have to have seen it. They have to have known. But he was a little frustrated. And I'm like, hey, I get frustrated too. I mean, I don't get mad at them. I understand math is not easy for everybody, right? So we got to be forgiving and stuff like that. Yeah, teachers do get, we don't get frustrated so much at you. We sympathize. We just get frustrated because we just wish it was easier for everybody, right? It'd be nice. That way everybody would do great and we, you know, everybody would be happy all the time. But on that note, by the way, for some of you guys, I think there's a couple of you guys in here, 2 or 3, maybe 4, I can't remember, where I put messages in your thing telling you, come and see me if you're having trouble. Okay, I'm here every morning. Every morning. So come and see me. All right, here's the next one. We have 6 examples, by the way. I'm trying to, you guys have 16 homework problems today, so I'm trying to knock down a lot. I don't want to do 8 because I think you might be falling asleep in about 10 minutes, so hopefully we can get everything done. But, you know, we'll move as fast as we can. So, same idea, okay? The only thing I'm going to tell you that you might want to do for this one, just so that you make sure you know how to rewrite it, is write it over 1. That way you know it is a fraction, so I'm going to do times the reciprocal of the second fraction, right? So I'm going to write this down right here. 56x plus 64 over 7x plus 8 times 1 over 2x minus 6. In case you guys are curious, the most commonly missed problems were numbers 1 and 2, which were actually some of the easier ones. But this is what I saw a lot of yesterday. So they got 7 and reduced with 56, and they got 8 and reduced with 64. Granted, you guys reduced it correctly, so I'm so happy about that, but that was not the right thing to do though, right? That was a very common problem in the first 2 problems, and then all of a sudden, people started getting everything else right, and I'm like, they did all the hard stuff just fine. I go, what happened, right? Some people did that mistake on number 1, and then on number 2, they didn't do it. Like, they did it correct, and I'm like, they didn't see it, right? So they're already on there, and I'm gonna see if I can give them back to you guys today. I gotta see how many people are still missing. But yeah, they're already up there. By the way, you guys did fine. Don't, just because I'm talking about it doesn't mean you guys like all got D's or anything. Like, no, you guys did just fine. I'm sure some of you guys probably got a grade a little bit below than what you wanted in some cases. Some of you guys missed like 1 point, stuff like that. But for the most part, you guys did just fine. So that's good. All right, so here we go. Now that we flipped it, let's go ahead and start factoring everything here. Binomials, we got to try to factor, right? So 56x plus 64. What goes into 56 and 64? An 8. Yeah, an 8. So we're going to put 8 here. This would be 7x plus 8. Does 7x plus 8 have a GCF on the bottom? No, right? So it's just going to be 7x plus 8 times 1 over 2x minus 6. What do they have in common? A 2, so this would be an x minus 3. All right, what can I cancel out? All right. So that's oddly satisfying. I don't know if you guys find that. That's very satisfying for me whenever I get to chop things up. Anything else I can fix? All right, I can get rid of that 8 and 2. well, not get rid of, I can reduce, let me say that correctly. So the 2 goes into itself once, into 8 4 times. So let me go ahead and multiply now. So I'm going to have a 4 over 1 times a 1 over x minus 3, which just becomes 4 over x minus 3. Now, what I like about these problems, me personally, is that it can look really, really complicated, but if I do it right, usually it simplifies nicely. It's kind of nice. If the problem you're doing looks worse than the way you started, then you're doing something wrong. Shouldn't look worse. All right, before we get into the last two, because I think this is example, oh no, wait, we got example 4. But before we get into complex, you guys have any questions on the first 3 here? Because the next one's supposed to be the hardest one on your homework. So I chose to do it just so you guys can see that it has like a little bit of trickiness to it. But, all right. So here we go. This is supposed to be the hardest one in the homework. I promise you the last 2 examples are very quick because even on the homework, they're all small little fractions. So that's the nice thing about the last 2. This is the last one that's actually going to require a lot of work from us, okay? Before I do anything, I want to ask you guys, do you see anything weird in this problem?
Squares.
Okay, the squares on the bottom, there's squares on the top. Anything specifically besides just generally the squares?
Variable.
Go ahead. Which one's not in order? Yeah, that's supposed to be a difference of 2 squares, right? It's x squared minus 4. That's the way it should look, but it doesn't look like that. But it's a minus. Can I just flip it?
Yeah.
Well, the answer is no, but yeah, I can. You guys said it, but what do I have to do?
You have to put the negative on the...
Put that minus, right? If you want to flip a minus, fine. Just put a negative in the front. And that's what I'm going to do because I want things to match up. And they're not going to match up if my variables are backwards, right? We always start with the highest powers and go down. Every sign will, well, within the 4 minus x squared, every sign will change when you do it. So like right now it's a positive 4, right? And a minus x squared. When I take the negative out, that 4 will become a minus 4 and the x will become a plus x. So it'll change it. But we're going to flip it so it can look nicer. So I'm going to do 2 little steps right now, okay? I am going to flip it like that. Okay, and then let me write this out. Again, some people like to do all the factoring at the same time. I'm okay with that. I'm just kind of taking my time here just so I don't lose people. All right, so I just did the flipping of the fraction and the times, and then I did the reversal of the top left part, making it x squared minus 4. All right. So, x squared minus 4. If I'm going to factor that, let me use a little bit of scratch paper on the side here. If I have x squared minus 4, that's the same as x squared minus 2 squared, which is x minus 2, x plus 2. All right, so let me put that right there on the left side. So x minus 2, x plus 2 over. Now let's do the bottom left, x squared plus 7x plus 10. Thankfully a is 1, so I don't have to divide. I know I'm kind of moving a little bit faster. I do apologize, but it's not because I'm rushed on time. It's just I want to make by now I think we should be getting a little bit quicker, right? So 1 times 10 is 10, and b is 7. So 2 numbers that multiply to 10 that add up to 7. 5 and 2, right? Positive 5, positive 2, positive 2, positive 5, doesn't matter, either order. So this would be x plus 5, x plus 2. I'm going to write that down right here. Times. Notice the bottom right of the fraction, x minus 2, nothing's going to happen to it. There's no GCF. It's not a difference of 2 squares. So I'm just going to write it here, just so you can see we only have one more that we got to do. The top portion, x squared minus x minus 72. So x squared minus x minus 72. I mean, I know the answer is x minus 9x plus 8, but like I said, I just want to show it. Negative 1, oops, negative 1, and c is negative 72. So when I multiply, I get negative 72 with the negative 1. And I think I kind of just told you guys the answer, right? It's going to be a negative 9 with a positive 8. Negative 9, positive 8. So x minus 9, x plus 8. X minus 9, x plus 8. All right, what can I chop? All right, what else? All right, anything else? No. So here's my answer. Well, it's negative 1. I guess not the answer yet, but let me rewrite it. But I'll get my answer from this. I'm just rewriting it so I see what's left, just to make sure I didn't miss anything. That's what it looks like now that I chopped everything up. So now just put it together, right? Multiply. So you get negative x minus 9, x plus 8 over x plus 5. Again, these are all homework problems, so we're not wasting time by doing a bunch of examples. I am progressing you, right? But we got 2 more, but these last 2, they're pretty quick. Okay, these always take a while. All the rest of your problems, I don't think there's any more trinomials, if I'm correct. Yeah, so this is the only problem where you have trinomials, where you got to do the x method. The rest of them are either going to be difference of 2 squares or GCF. So they'll be easier. Okay, so that's what, like I said, I did the harder one for you guys just so you can see it. All right, so how do we do complex fractions? Okay, well, it's the same way that we did the stuff we just did right now. I always tell people, if you're confused with what you see, just say it in your head and write it down when you say it. Okay, so I'm going to say it out loud and write it down. So here we go. This is what I see. 4/5 divided by 1/3. That's what I see. Well, look there, I simplified it now. So all I got to do is use the little trick, right? Don't divide fractions, multiply by reciprocals. So 4/5 times 3/1. Yeah, just multiply across. I don't have anything in common, so this becomes 12/5. Done. The hardest part is the translation from the original problem to that first step that I did. That's the hardest part. But all you got to remember is just say it out loud to yourself, right? And write it down as you say it. Okay, as long as you do that, you should be able to write the problem in a different way and then just multiply into it. So same thing for number 6. I know it looks complicated, but if I read this out loud, this is what it says. X plus 2 over 3x plus 2 divided by x plus 2 over x minus 3. And once I do that, then the rest is easy. I'm just going to change the division to times and flip the second fraction. So, all right, x plus 2, that one can't be reduced. 3x plus 2 also can't be reduced. Times x minus 3 over x plus 2. So I just multiplied and flipped the second fraction. Can I chop anything? The x plus 2's. Yeah, I can get rid of this. So that'll become a 1, 1. So let me just rewrite it and then we'll multiply. Remember, guys, I always show more steps than are really necessary. If you don't need to do this many, feel free to skip, okay? The more comfortable you are with the math, the less you have to do. So there you go. So hopefully you guys don't find this like brand new, right? It's all basically the same thing, just one little extra step. And this is a little different, but you've learned this before a long time ago. But it just looks a little bit harder, but it really isn't that difficult to do. Just say it to yourself, write it out as you say it, okay? That way you know how to write it out long-wise instead of a complex one. So let me go ahead and stop this, and I'll give you guys your homework.